Welcome back to another lesson in which we're going to have some example problems on solving compound inequalities. Make sure that you watch our previous lesson on the explanation for compound inequalities before attempting this lesson to help prepare you better. So let's get right to the practice problems. In front of us, we do have the following compound inequality: x less than or equal to -1, or x is more than 3. Now, obviously, this is already the solution. It's quite straightforward. However, we need to draw the number line for this to perfectly represent our answer. So if you notice in this current case, this is a very simple problem. I'm going to add the following number line where I have 1, 2, and 3, and 4. I'm going to have -1, -2, -3, and -4. So let's take the first condition. X is less than or equal to -1. So -1 is going to be included in my solution. So in this current case, I'm going to put it as a full solid point. X is less than or equal to -1. What's less than -1? Obviously -2, 3, 4, and the list goes on, going all the way to the end, to infinity in this case. So we have satisfied the first condition. Let's go to the second point. X is more than 3. So we have or x is going to be more than 3. So this is 3. We are going to keep it as a hollow point because there's no equal sign. So the answer will be all the way to infinity in this current case. So if you notice, in this current condition, I've satisfied the compound inequality. What I've said, x is less than or equal to -1, which goes all the way to the left, or x is more than 3, which is this hollow point at 3 because 3 is not included, and going all the way to the right. This satisfies both of my conditions. Now let's go to the second problem, which is an AND compound inequality. And let's follow the same approach. We have the following number line, and I'm going to add the following points: 1, 2, 3, and 4. And here I'm going to have -1, -2, -3, and -4. Now, based on the first condition right here, x should be more than or equal to -2. It should be bigger than -2. So what's bigger than -2? Be careful right here. -1 is bigger than -2, not -3. Because being more in the negative, it means you're getting lower. So we have -2. all the way included. That's why we had a solid point all the way to infinity in this case. This is the first condition. But since we do have AND, we should make sure that the second part is included as well. So we're going to say x is less than 3. So where's 3? 3 is going right here as a hollow point. We're not going to include 3 because there's no equal sign. And we're going to go all the way to infinity in this direction as well. Now, since we do have an AND condition, we should satisfy both. And in order to satisfy both, we should be in the part where both of these solutions meet, which is in this current case where we have x is less than 3, right, which is right here, and more than equal to -2. So these are the solutions for my compound inequality because it satisfies both of these conditions. So you have to be careful with the AND compound inequality because you have to satisfy both parts of the inequality to make sure you got the right answer. So let's recap how we have done this. We've said that x is greater than or equal to -2. So I went to -2 because I have an equal sign. I'm going to include -2. And we're going to go for the greater direction, which is positive all the way this way, which is infinity. And x is less than 3. We're going to go to 3, add a circle, empty circle, because there's no equal sign, and go all the way down. So where's the part where both of these solutions meet? More than equal to -2, less than 3. It's between this point and this point, right? This is the area where actually my conditions for both inequalities has been satisfied, where x is going to be less than 3 and more than or equal to -2. Basically, they look the same way. right? So this is how I've drawn my number line for the current simple compound inequalities. So let's take it a step further. What if I want to find the solution for the current compound inequality? How would I do this? First of all, when you see that you have two conditions that you need to satisfy, the first thing that should pop to mind, this is an AND compound inequality. So I can separate it to two different parts where I can say I have the first part, minus 4x plus 3 is greater than or equal to, because this is the condition right here, where minus 4x plus 3 is more than or equal to minus 3. Just simply flipped it around to make it easier. Then, and, right? The second condition where I have minus 4x plus 3 is less than or equal to 10. So I have separated my initial compound inequality, because I have two conditions, into two separate parts. This is the first step that you need to do. Then what I'm going to be doing is I'm going to solve every single one of them by itself. Now I'm going to add 3 over here, plus, actually on the other way around, minus 3 actually, to get rid of the plus 3, minus 3, and then minus 3. I'll end up having minus 4x greater than or equal to minus 6. Minus 3 is minus 6. Now in this current case, I'm going to be dividing by minus 4 to get rid of the 4, divide by minus 4 as well, where the answer will be x is greater than or equal to, what is 6 over 4? If I divide by 2 over here and divide by 2 over here, I'll end up having 3 over 2, which is 1.5, right? So x is greater than or equal to 1.5. So this is the solution for the first part of my compound inequality. Let's go for the second part, which is right here. So I'm going to follow the same steps. I will say minus 3, and then minus 3. I'll end up having minus 4x less than or equal to 10 minus 3 is going to be what? It's going to be 7, right? 10 minus 3 is going to be 7. Now, if I'm going to crunch in these values, you can use the calculator depending on the complexity of the problem. Now, keeping in mind that some of the problems, they're quite straightforward, that you do not have to use a calculator, but other problems you should be using a calculator. So I'm going to say in this case, divide by minus 4, right? And divide by minus 4. So what do you end up having with, in this current case, keep in mind that since I have divided by minus 4 in both sides, I have to be careful about my sign, because the first part I have 7 divided by minus 4. It's not minus 7 over minus 4. So you have to be careful here. So in this current case, I have to flip my sign, where I have x is greater than or equal to, what is 7 over 4? If you put it on the calculator, it's 1.75. We have a minus sign, so I'm going to say minus 1.75. This is the second condition. How have I done it? Let's recap the steps. I said minus 4x plus 3 is less than or equal to equal to 10. So I've eliminated the 3. I said minus 3 and minus 3. Then minus 4x less than or equal to 7. Divide by minus 4 and divide by minus 4. Now, why did I flip the sign? Because I've divided by a minus sign and the numerator on the top is positive. Now, if it's minus 7 over minus 4, we are going to keep it the same way. We are not going to be doing anything about it. We are not going to flip it. But since we have been dividing by a negative sign and the top is positive, we have to flip it. So if I do it the other way around, I just simply divide by 4 and divide by 4. I have minus x less than or equal to 1.75. So I have to multiply by a minus sign now to get x positive. So it will be x greater than or equal to minus 1.75. So I have my two parts of my compound inequality. Let's try to sketch the solution over here where we have the following condition. If I have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, this is more than enough for the time being. So let's plug in the first part. I have x is going to be more than or equal to 1.5. This is 1.5. Here we have a solid point greater than or equal to. Here we go. And x should be more than or equal to minus 1.75. So minus 1.75 would be somewhere here. So I'm going to go all the way as well. Now, where do you notice they meet? Since it's an AND condition, I should satisfy the first one and the second one, correct? So in this current case, the following conditions are satisfied at this current part, where they intersect with each other. And where do they intersect with each other? At the point of x more than or equal to 1.5, right? So when x is more than or equal to 1.5, it satisfies the first part and the second part, because this part is not going to be included, right? Because this part only satisfies this current condition but doesn't satisfy this current condition. So when we are dealing with, again, AND condition, we should satisfy both of them. We've said for the first condition, x is greater than or equal to 1.5, which is from this point onwards. X greater than or equal to minus 1.75, which is from this point onwards. So where do they both meet? This part and this part at this current location, right? If I sketch it again, it will be all the way here. So they meet at exactly this current part, which is x more than equal to 1.5. So this is how we solve a compound inequality where we have an AND condition. Let's take another example where we simply take the same inequality and we play with it a bit to have an OR condition. So in order to do so, simply solve it every single piece by itself. I will say I have minus 3 over here, minus 3 over here, minus 4x greater than 7. I'm going to do a different approach over here just simply to make sure that the previous part, how I got this solution, is clear for you. Divide by 4 without the minus sign. Divide by 4 without the minus sign. You'll end up having minus x more than, okay, 7 over 4. Now multiply with the minus sign. It will be x is less than, right, minus 7 over 4. So in this case, x is less than minus 1.75. Right? Now keep in mind the problems that we have, this problem is different than this problem. There are different conditions just to avoid confusion. But why I've dealt with this step differently compared to this previous step, just to make sure that you got this part right. So in this case, we have x is less than minus 1.75 for the first condition. Let's apply for the other condition where we have OR. I'm going to say minus 3, minus 3. I have minus 4x is less than 2, right? Now I'm going to divide by minus 4 directly and divide by minus 4 such that x, don't forget to flip the sign, is more than minus 0.5, because 2 over 4 is 1 over 2. Divide by 2, we have 1 over 2, which is 0.5. So by dividing by minus 4, 2 divided by minus 4, we have minus 0.5, and don't forget to flip the sign. So this is my second condition. So let's draw the number line right now where we have the following answers, such that I have here 0, 1, 2, and 3, and I have minus 1, minus 2, minus 3. Now for the first case, x is less than minus 1.75. It means I have to go lower. Keep in mind it's not included, so you put a circle, empty circle, and then drag it all the way towards the end. This is the first condition. Now for the second case, we have x is more than minus 0.5, which is going to be right here. More than minus 0.5, we have to go all the way to the right side. So we have satisfied the second condition. Since we are dealing with an OR compound inequality, our solutions are x less than minus 1.75 or x more than minus 0.5. These are basically my solutions satisfying my compound inequality in this current case. Now, recap the previous examples, go through them again, make sure that you replay the video multiple times, pause and try to get the steps done by yourself, and make sure that you try to attempt it before looking at the current answer in front of you. And I truly hope that these current example problems help you understand and implement the concept of solving compound inequalities.